You step out of your time machine, find your grandfather years before your parent was conceived, and you pull the trigger. But if he dies, your parent is never born, which means you are never born. And if you're never born, you can't build a time machine and travel back. Therefore, your grandfather lives. You are born, you build the machine, and you travel back to shoot him. It's an endless, contradictory loop. This thought experiment wouldn't be a problem if time travel were strictly science fiction. But Einstein's theory of general relativity actually allows for something called closed time-like curves, paths through space-time that bend backward and loop in on themselves. The existence of these loops is a direct threat to causality. That is, the core rule that a cause must always happen before its effect. You drop a glass, then it shatters. The effect cannot logically erase its own cause. If you can break causality by assassinating your own ancestor, the basic logic of physics collapses. To prevent reality from unraveling, the universe must have a built-in defense mechanism to stop you from successfully firing that gun. The first line of defense assumes we live in a single, unchangeable timeline. In this scenario, the universe actively intervenes to thwart your assassination attempt. You pull the trigger, the gun jams. You try again, and you slip on a puddle. This is codified in theoretical physics as the Novikov self-consistency principle. Proposed by Igor Novikov in the 1980s, it states that in a closed timeline, the mathematical probability of any paradox-inducing event is exactly zero. You can physically travel to the past and walk around, but you are mathematically restricted from performing any action that contradicts known history. Your actions are already baked into the timeline. To save the law of cause and effect in a single timeline, the universe sacrifices your free will. Every failure to eliminate your grandfather is a fixed, predetermined component of the historical record. But what if we step outside classical physics? What if we move into quantum mechanics, and you actually do manage to pull the trigger? Physicist David Deutsch proposed a solution known as the DCTC model, which relies on the many worlds interpretation of quantum mechanics. In this framework, altering the past forces reality to split. The moment the bullet strikes, you enter a new parallel timeline. Your original timeline continues undisturbed. Meanwhile, in this new branch, your grandfather is dead, and you exist as an anomaly with no biological origin. Causality is preserved by sacrificing a single unified reality. You haven't erased your own grandfather, you've only erased a parallel version of him. Branching universes are an escape hatch, but what if reality is confined to a single, non-branching universe? How does quantum physics protect causality? This brings us to Seth Lloyd's PCTC model. Instead of relying on alternate dimensions, this model uses a quantum process called post-selection, which filters outcomes based on probability amplitudes. Think of quantum states as waves. In Lloyd's model, if a sequence of events leads to a paradox, the probability waves representing those events undergo destructive interference. They overlap completely out of phase, meaning they mathematically flatline and cancel each other out to zero. Reality acts as a strict mathematical filter. The universe doesn't need to jam your gun or create a new dimension. It simply dictates that the only physical states permitted to survive into existence are the ones where you fail. These theories all assume you can successfully build a time machine in the first place. But there is a final, cosmological scale of defense that stops the paradox before you even start the engine. In 1992, physicist Stephen Hawking proposed the chronology protection conjecture. Hawking argued that the exact moment a closed time-like curve is attempted, quantum vacuum fluctuations build up exponentially along the loop. This creates an infinite surge of energy that instantly collapses the wormhole or time machine structure. This mechanism makes the universe, in Hawking's words, naturally safe for historians. It guards the timeline directly, stopping macroscopic time travel at the source without relying on jammed guns or parallel dimensions. The grandfather paradox is the ultimate stress test for theoretical physics, and whether the solution requires stripping away human free will, fracturing reality into a multiverse, or annihilating wormholes with infinite energy, the conclusion remains: nature will relentlessly protect the law of cause and effect.